Alright, so welcome to the final video guide for the chain rule. And for this video guide, I will start the problems off with question number 2 in example 12. And in this problem, we're given the table of values, and I'm given this function here, and I have to take its derivative, and I need to evaluate the derivative at g prime of 4. So that means I need to find the derivative when x equals to 4. Okay, so let's go ahead and take the derivative of this composite function here. And when you're taking the derivative of a composite function, you want to take the derivative of the outside term first, so that would be g prime. And then you would go ahead and copy out the rest of the expression. And then the chain rule states that you need to take the derivative of the inside guy. So the inside guy is f of x, and the derivative of f of x is f prime of x. Okay, so now we want to evaluate the derivative when x equals to 4. So anytime you have an x value, those x values will change to 4. So this would be g prime, and this would be f of 4, close the bracket, times f prime of 4. Okay, so let's go ahead and find out what f of 4 is. In order to find f of 4, I need to go to my table of values. So here's f and here's 4. So f of 4 has a value of 1. So this whole expression will now be 1. So now I have g prime of 1 times f prime of 4. So f prime of 4. So here is f prime. There's 4. So f prime of 4 has a value of -2. So this will be -2. And then finally, I need to find the value of g prime of 1 now. So here's g prime. Here's 1. So g prime of 1 would be -3. So this is going to be -3 times -2. And -3 times -2 has a value of 6. Alright, so let's now move on to problem 3 in this section here. Okay, so for problem 3, I'm given another piecewise function here. I'm given p of x equals to all of that, and I need to find the derivative value when x equals to 1. So this happens when x equals to 1. Alright, so let's go ahead and find the derivative of p of x. So p prime of x equals, alright, so once again I have a composite function, and for composite functions I always look to the outside function first. So that's going to be f prime. So when I take the derivative, that will be f prime, and then I need to copy out the rest of the problem. And then the chain rule states that I need to take the derivative of the inside function. So the inside function that comes first in this composite function is g, so it would be g prime, and then I would copy out the rest of the problem, which is 2x minus 1. And then finally, the chain rule states that I need to continue taking the derivative of the inside term. So the derivative of 2x minus 1 is going to be 2. Okay, so after that, I need to evaluate this when x equals to 1. So this will be p prime of 1 equals. So anytime I see an x value, those x values will be replaced with the value of 1. So this will be f prime. This is going to be g bracket. Well, if I plug in 1 here, that's going to be 2, right? So 2 times 1 is 2. And 2 minus 1 will give me a value of 1. And then this will be g prime. And once again, if I take a look at this expression right here, if I let x equals to 1, I will have 2 times 1, which is 2. And 2 minus 1 is 1. And then the red 2 will remain at the very end. Alright, so let's just go ahead and move on with the problem here. So let me highlight the g of 1 here and g prime of 1. We need to find those values from the table. Okay, so for this expression g of 1, I need to go find my g value. So here's g, here's 1. So g of 1 has a value of 4. So this will now become f prime of 4, f prime of 4, and then times, well, what's g prime of 1? Here's g prime, here's 1, so g prime of 1 has a value of 3, so this will be -3, and then I'm going to multiply that with 2. Alright, so what's f prime of 4? Well, here's f prime in the table, here's 4. F prime of 4 has a value of negative 2. So this will be negative 2. And the rest of this remains the same. This will be negative 3. And this will have a value of 2. And I just need to multiply all that out. So that will have a value of positive 12. So positive 12 is the answer for question number 3. Okay, let's move on to the next one. Let's skip question here. All right, so the next one is question number 4. So now I'm given t of x, and I need to evaluate this expression when x equals to 2 in this case. All right, so let's go ahead and take the derivative. T prime of x equals. All right, so the composite function is when you're taking the derivative of composite functions. Once again, you always go with the outside first, so that'll be f prime. And then I copy out the rest, which will be f of x squared, close bracket, and then the chain rule states that you take the derivative of the next term on the inside, which is f, so that'll be f prime, and then the rest of the problem remains the same, and then the chain rule says you take the derivative of the inside guy, and the derivative of x squared is 2x. Alright, let's go ahead and now evaluate t of t prime of 2. So if I go ahead and do this very carefully here, this would be f of, okay, so if I plug in 2 here, 2 squared is going to be 4, so that gives me a value of 4. And then I close the bracket, and then f prime, well, f prime of what? Well, 2 squared is going to be 4. And 2 times 2 is going to be, 2 times 2 over here. If I plug in 2 there, 2 times 2 is going to be 4, so 4 at the very end as well. Okay, let's continue to evaluate this. T prime of 2 equals. Okay, so what is f of 4? Alright, so f of 4, I need to go to the table of values here. So here's f and here's 4. F of 4 has a value of 1. So now this is going to become f prime of 1 times, now what's f prime of 4? Well, f prime of 4 on the table has a value of negative 2. So that will be negative 2, and then I need to have another 4 at the very end. Now we need to evaluate f prime of 1. And f prime of 1, if I go to my table here, well, here's f prime in green, there's the 1. F prime of 1 is 4. So this expression here has a value of 4. So 4 times the negative 2, and then I times that by the 4 at the very end. If I multiply all those numbers out, I should get negative 32. So 4 times 4 is 16, and 16 times negative 2 gives you negative 32. Okay, let's move on to question number 5. I believe this might be the last question in the homework section for the chain rule. Alright, so we have more composite functions, and we're evaluating the derivative when x equals to 1 there. Alright, let's go ahead and take the derivative now. So composite function, you always work on the outside first. So f prime of bracket 3x minus f of x cubed, close the bracket, and then I need to take the derivative of the inside term. So the derivative of that is going to be 3 minus, and the derivative of f is f prime of x cubed, and then using the chain rule you take the derivative of the inside guy, which will be 3x squared, and then you would just finish off by closing the bracket there. Okay, so let's go ahead and now evaluate this when x equals to 1. So this will be f prime of, okay, so this x value here, which I'm going to highlight there in yellow, these x values all change to 1 now. So this is going to be 3 minus f of 1. And then I need a blue marker here, close that off. Then a red marker, 3 minus f prime of 1, close the bracket. And at the very end here, if I plug in 1 here, 1 squared is 1, and 1 times 3 is 3. And then I can close the bracket with another red. Sorry, I can finish the expression by closing off the bracket there. Okay, now we need to go ahead and just start evaluating as much as we can here. Okay, I think this, I just need a little space here. Okay. All right, so f prime of 1, let's go ahead and find that. Here's f, here's 1, so f prime of 1 is 2. So q prime of 1 would equal to f prime of 3 minus, now this expression right here, f of 1 has a value of 2. And then I can close off that. And then I'll use my red marker now. 3 minus. Now ask yourself, what is f prime of 1? Well, here's f prime, there's 1. F prime of 1 has a value of 4. So this is going to be 4 times 3. And then I'm going to close the bracket. Okay, let's move on to the next line here. So this will be f prime of, well, 3 minus 2 is going to be 1. Times, well, 3 minus 4 times 3. Well, 4 times 3 is 12, and 3 minus 12 has a value of negative 9. All right, let's finish off here. The problem here, f prime of 1. Well, f prime of 1, if I go to the table here, I mean, there's f prime, there's 1. F prime of 1 has a value of 4. So this will be 4 times negative 9, and the final answer here is going to be negative 36. Okay, so that concludes the homework questions for the chain video, the chain rule video, and we'll see you guys on the next homework video guide.